In the first slide, I will be discussing nucleosynthesis, the process which creates elements. Nucleosynthesis, as defined in the slides, is the process that creates new atomic nuclei from pre-existing nucleons, primarily protons and neutrons. The three types of nucleosynthesis are demonstrated by the diagrams on the slide, with the Big Bang nucleosynthesis diagram in the top right, then the stellar nucleosynthesis diagram in the bottom left, and then the supernova nucleosynthesis and merging neutron star diagram in the bottom right. Big Bang nucleosynthesis began the first millisecond after the Big Bang, when temperatures had dropped enough for quarks to begin forming neutrons and protons, with the ratio being 7 protons for every neutron. Free neutrons are quite unstable with a half-life of around 10 minutes, but most neutrons had paired up with protons, and these pairs went on to make up helium atoms and isotopes. This process slowed down dramatically after only 3 minutes, with the ratio of elements remaining relatively fixed for the next 200 billion years. This ratio was 75% hydrogen, 25% helium. Diagram 1 shows the protons and neutrons forming an isotope of hydrogen, which then goes on to form helium. Stellar nucleosynthesis, nuclear fusion in stars, creates elements from helium to iron on the periodic table, but no more than this. This is because nuclear fusion is a process of smashing together light elements to create heavier ones, with light and heat being released as a consequence. Elements after iron on the periodic table require too much energy to create via nuclear fusion from stars. The diagram in the left-hand corner is displaying the creation of carbon, which is formed by a nuclear reaction between boron-8 and helium-4, forming the isotope carbon-12 and a gamma ray. Supernova nucleosynthesis is believed to produce heavier, rarer elements via rapid neutron capture, the process of neutrons landing on a nucleus faster than they decay, which may occur during supernovas, helping build nuclei for heavy atoms like gold. What happens during this process is seed nuclei, for example iron, gains lots of neutrons very fast, and some of those neutrons decay into protons and electrons, leading to new elements being formed. However, a merger of two neutron stars is a new process being proposed that is also likely to produce heavy elements in much larger quantities. The third diagram in the bottom right-hand corner is displaying the differences between rapid neutron capture in supernovas and merging neutron stars, with neutron stars believed to create far greater amounts of heavy elements, although the collisions occur far less than supernovas.